Pull out your hose and grab your can. We're about to integrate another Pest Geek podcast. Hi, everybody. Frank Hernandez here, and welcome to the Pest Geek podcast, bringing you the latest news, products, and politics from today's leading industry pros, offering you their technical marketing and growth strategies to give you, the pest management professional, that killer edge. Hi, everybody. This is Frank Hernandez, Pest Geek here, and I have on the phone today Dr. Nan Yao Su. He's a professor of entomology from the Department of Entomology and Nematology at the Fort Lauderdale Research and Education Center at the University of Florida in Fort Lauderdale. Now, his education, he's got a master's degree from the Kyoto Institute of Technology in Kyoto, Japan, and he's also got a PhD in entomology from the University of Hawaii in Honolulu, Hawaii. He has been mentioned in over 300 referred and non-referred academic and scientific publications, and he has been in about 15 books, including Biological Activities of Bait Toxicant for Population Management of Subterranean Termites, page number 87 through 96 in Household Structural and Residential Pest Management from Oxford University Press. He has been involved in about 7 international activities, including Chief Technical Advisor for Termite IPM in China, a World Bank project for elimination of persistent organic pollutants, the Ministry of Environmental Protection, People's Republic of China, 2007 to 2011. He also has 19 distinct honors and awards, including International Fellow of the University of Florida Institute for Food and Agricultural Science, 2012, a Charter Fellow of the National Academy of Inventors, 2012. He also has endowments in scholarships, including Desmodium Fund, International Center of Insect Physiology and Ecology, Nairobi, Kenya. And if this weren't enough, he's also now an inductee of the Florida Inventors Hall of Fame for his invention of the Centricon system for termite colony elimination. He's right up there with Henry Ford and Robert K., the inventor of Gatorade. Dr. Su, welcome to the podcast.
Thank you.
Well, let me ask you this, because, about the only thing you're missing is a New York Times bestseller.
I'm working on it.
You're working on it. So so I take it that Termites for Dummies is in the works?
Well, you will know when it comes out.
All right, I'll be looking for it, most definitely. Your latest article that I was reading and that I came across was the hybridization of 2 major termite invaders as a consequence of human activity.
Yep.
First of all, for the audience that might not be familiar with hybridization, what is hybridization?
Hybridization refers to a mating of 2 different species. Usually, that would result into, most likely, it's a sterile individual. Like, for example, you can mate horse with donkey. It can produce a mule. Mule is a very powerful animal. Still can kick and carry, a very sturdy animal. But mule are sterile. They do not reproduce by themselves. And that is most of hybridization. But we don't know at this point if this hybridized termite we are seeing here is sterile or fertile. We don't have no idea at this point.
Okay. And then my next question is going to be, when did you first realize that this was occurring?
Those are 2 different species, right? Formosan and Asian subterranean termite. Based on our knowledge, we know Formosan termite tend to live in the subtropic to temperate area. They live in a little cooler climate. The Asian subterranean termite tend to be more tropical species in a hot, humid environment, and that's they come from Southeast Asia. And so we knew that Formosan termite is in South Florida for a while, but we know this pretty much from North Miami Beach all the way up. And in the beginning, we did not have Formosan termite. And then in 1996, we first found the Asian subterranean termite in Miami, near the Miami Port area. And that's kind of thought, okay, this species first appeared in Florida, But it still makes sense because Asian Southern termite in the tropic, in the more south, in the middle of the Dade County, and they're separate from each other. Formosan termite from Dade County up. Well, that picture changed in 2001 when we found one infestation of Asian Southern termite in Broward County. But in the beginning, we thought, okay, this is kind of maybe exception in the case. Maybe this just doesn't just fluke or some kind of biology of a lot of flukes. Sometimes exception happen. They may just go away. Well, they did not. From 2001, 2002, and by 2006, we found out the Asian Southern termite had spread all the way to Riviera Beach. Now we have like a two major overlap area from Dade all the way to Palm Beach County. But that still does not mean they will interact with each other because mating season is different. Although they are in the same place, but many species have a different mating ritual, mating courtship behavior is totally different. So they usually don't mate. And a major thing this separate these two species we thought previously was that Asian Southern termite swarm from February until mid-April. And as soon as they stop swarming, the Formosan termite start swarming from mid-April, all the way to June. That's what I thought. That's why I did not think they would do anything to each other. Well, that picture changed in 2013. Dr. Shovank, who is also first author of this paper we published, in his own backyard in Broward County, he found out when he during the swarming season, he was catching those swarming termites. He found both Asian and Formosan termite swarms simultaneously. And that is a really first time we found out this is really strange. Something strange happening here. So 2014, he set up a trap to capture those swarming termites from February all the way to June. And we find out that what our previous assumption were wrong. Yes, indeed, Asian Southern termite began swarm in February, but they swarm all the way up to June. And then Formosan termite did not swarm beginning from mid-April, that's like we thought they should. Instead, they swarm from mid-March. So we have a 2 and a half month solid month of overlapping or swarming between the two species. That is really first time we confirm something is going on here.
Gotcha. So what you're saying is that these are these paradoxes of these two, they shouldn't be mating because of that reason. But what do you think triggered that event or that condition for them to be able to actually swarm at the same time or overlap in that way?
Well, you have to think about this, right? Because at this point, we all speculation. We have no idea or solid evidence as to what's going on. But we can kind of point out to what really triggers swarm. There's only two things you can think of that dictate the seasonal activity of insect. It's insect in general. One is the daylight length. That means that when the winter daylight, short winter, have a shorter daylight during the winter, start coming out of winter, the daylight start to increase certain point, insect are triggered to start to mating. That's a spring coming in, or daylight coming up, okay? So, and then when the daylight started, from summer, longer daylight started to shorten, a lot of insects sense that winter is coming, they move on to the next activity. For example, in the north, some insects go to hibernation or go to diapause. They will not produce again until the next spring comes. That daylight is one of the major factor dictates seasonal activity of insects. The number two factor is temperature. Many animals will sense the temperature start warming up. They will engage into spring activity, and when the temperature drop, but toward the end of summer and go to fall, they go stop activity. So the two things really dictate insect activity, seasonal activity. The number one thing, daylight length, has not changed. That's dictated by how Earth tilts toward the sun, right? It has not changed. So we have to move on to the second one, which is the temperature. Has temperature really changed in recent years? Yes, they did. what we are seeing so far, for example, if you take the mean average temperature, daily temperature between November all the way to April in Dade County, for example, and that's the time that termite is swarming, and they'll have to determine the swarming happening, is that from 1976 all the way to 2014, if you look at temperature, it's a steady increase. It's steady increase of temperature over the time, not just temperature stuck in warmer, but also we have a more drastic change in the temperature, in the daily temperature. In the midwinter, for example, all of a sudden we have experienced an unseasonably warm day a couple of times. Then in the supposed to be warmer time, we have an unseasonably cold temperature drop off. The temperature change definitely have to have some effect of the timing of the swarming of these two species. And that's kind of my speculation.
Okay, so we're looking at the increasing temperature change, and that seems to be then a possible trigger. You mentioned
Right.
it in the article that it's in the title of the article. It's the consequence of human activity. Can you dive into that a little bit?
Well, there's two things happen here. One is for anything to happen simultaneously, you have to have two things. Have a location and time. You know, if I put an animal in the same location at the same time, they'll meet each other, right? Mm-hmm. There's no exception for that. So these two species supposed to be living in different parts of the world. Well, we human beings brought them together. The reason why we have a Formosan termite and Eastern Subterranean termite in our area is because we brought them in accidentally. And these termites hitchhike into some of the wooden material, most likely the wooden boat itself, and they will come into the port area in Miami and Broward, those port area, and they will spread from there to the rest of the state. So we are responsible for transporting them to the same place, the two species. That's number one. Number two, I tend to believe that we are the one causing this temperature change. And this temperature change also messed up their timing. So with these two things initiated by human beings, it is totally man-made effect, what we are seeing here.
So when did the Asian termite first enter or first discovered in here in South Florida?
1996.
96, okay. And then the Formosa termite?
Yeah. Was first discovered in 1980.
Okay, so not that really long ago. It's not like we've had it here for 50 years.
Not at
it's been
all.
less than about 30 years?
No. Yeah, something
okay,
like that. And they're probably coming here earlier than that. When you find them, does not mean they just arrived. You know, usually people don't know they even exist until much later we find, this one exists here. But that's usually, you have to count probably 5 to 10 years before we confirm they exist here. These termites are still already here.
Right. Now, there's 3 unique places that you mentioned that these are overlapping each other with. Both of them exist. One of them is being Florida. The other one is Honolulu. And the other one is, it's Tainan, I believe, or Taiwan?
Taiwan.
It's Taiwan. Okay. And so potentially that similar problem can occur in those places also or do they have a different temperature and different,
Well, I think it's already happening.
It's already happening.
And the reason why we never heard from them is because nobody really noticed it yet.
Yeah.
And so that is really the reason why, for example, tomorrow I'm going to Hawaii. And that's one of the things that I want to spend 1 week there looking at is what's going on there.
Gotcha.
And, we put in the same place and in the same time. But that does not mean they were made. And so initially when we found them, they swarmed at the same time, we still did not think they're going to mate until we kind of just for the sake of a trial, we put in a petri dish in the lab. Mm-hmm. We thought they were never made. Well, they did.
Wow. Okay.
we thought if they're made, a lot of time have a zygotic issue. That means that their sperm and their eggs are not compatible with the DNA. So even their eggs, some of the eggs just won't hatch. Well, guess what? They did hatch.
Gotcha.
some hybrid individual are very, very weak. They will not be able to survive because there are a lot of complications with this problem. Guess what? They survive. And we thought they survive. The product doesn't grow very well. They did grow much better than their parents. So instead of seeing this complication problem associated with hybridization, we are actually seeing hybrid bigger, meaning that just like a mutt, the mixed breed of dog is sometimes more robust and pure breed. We are seeing something similar to that. The colony, 1 year colony that we have hybrid have a double the population size of parent colony.
So even though they cannot breed among themselves, once you have this hybrid, the way that they can populate still makes them very dangerous, even if they can't reproduce themselves.
Yeah. So we don't know if they reproduce themselves or not.
Gotcha.
That needs to be confirmed. But even without that, from Dade to Palm Beach County, where these two species exist, you already have a lot of hybrid population in the soil. Okay, that's probably already going on for a while before you would notice something here.
Right.
And those colonies probably, for one thing, we're sure that they grow faster. But is that all we're going to see? We don't know. If that's growing faster, or the final population size is bigger, could be. But we have to confirm that. How about each individual? Is that just because the bigger number or faster growth, or each individual consume more wood? We don't know that either. That's something we need to also confirm. There's a lot of things we need to study with this hybrid population.
So we're pretty much seeing what we consider to be the tip of the iceberg, and as that's always the case, you really until you deep further you won't know. But we're seeing that tip of the iceberg now.
Yes.
Regarding the methods and materials used for your study, what was the collection like? I mean, how many of these did you have to collect, or did you collect to be able to do a study?
Well, in 2014 we collect probably a couple thousand, and this year we probably exceeded a lot more than that. And then we are basically collecting from the field, and then we're mating them in the lab and create a hybrid population so that we can study what's going on. In the lab right now, we probably have a couple thousand hybrid colony kind of growing in the lab.
How long does one of these colonies take to become a mature colony? I mean, what period of time are we looking at in time? For the
normal Formosan or Asian subsistence termite, you're talking about probably 5 years.
Okay.
And with this hybrid, maybe faster because we know they grow at a double rate.
Wow. So we're looking at within the next 2 to 5 years a potential problem that we really still don't understand at this point. And explain the tandem behavior, because you did several studies with male, female of each one. Explain the tandem behavior.
Well, tandem behavior is when the Aedes, the swarmer, will fly in the air and then drop on the ground. Basically, the female Aedes will start running around looking for some suitable place to form a nest. The male typically will follow her tip and her abdomen tip, and he would just follow her like a tandem. So like a two individual will kind of move around like a pair.
Okay.
That's what's called tandem behavior. And we used to think that, well, most animals different species will not mate because the chemical they use or attractant they use for the male to follow the female is probably different. And that's how different species separate from each other. Well, guess what? With Asian and Formosan termites, both male of both species are attracted to Formosan female. So there are more Asian subsistence termite male would follow the Asian Formosan termite female than their own species, which is kind of peculiar.
Right. So the male Asian is really attracted to the pheromone of the female Formosa, and that's what's making
right. That's correct.
Okay. So that's just for my clarification.
Yeah.
In the rearing, can you go a little bit about how you went about, or did this just happen naturally, and you discovered this, or was there something that you tried to do to manipulate them to breed?
No, you don't have to manipulate anything. The typical procedure for mating a 8A pair of any termite is to create a small container, in a plastic container. Inside there, we'll put a little soil at the bottom and put a piece of wood inside there and fill them up with agar. Agar is the kind of substance we keep the moisture inside those containers. Then we drop one male, one female inside there and cap them and put in the incubator at about 28 centigrade. And then they will start eating those wood, laying the egg, and they start to grow inside this small container. And when the population grow bigger, then we transfer them into a bigger container, and eventually become very big colony. And that's a normal protocol we use for any termite species to create our own laboratory colony.
Okay.
Now with this hybrid, you just have to do the same thing. You don't have to manipulate anything. They will just grow fantastically.
They'll do their own thing. Okay. And now, with regards to then, after you were able to rear them and get some population going, you performed. You needed molecular confirmation with DNA,
right,
and mitochondrial. So what I wanted to know is, as far as with the DNA, and explain the difference, because I know that you're doing satellite genotyping and things like that. So what I wanted to find out is, can explain that process and what the difference is and what those allow you to understand.
Okay, so when these two species mated in the lab and producing egg, and the offspring start to appear, worker soldier appear, start to form a big colony. One suspicion I had is that this could be totally fooled by this. The female could be mating with her own species in the field. First, receive a sperm from the same species male, and then when we brought them back to the lab, she's already pregnant, but we mate them with the other species, and then therefore the offspring could be one species. That's what we thought. Because a lot of time the insect will mate and they have a thing called spermatotheca, which is a little sac with inside the female body that they will store the sperm. And then sperm will come out, one by one and inseminate the egg, and that's how they become fertile. So we thought that the female maybe already store a large quantity of the sperm from the same species, the male. That's what we thought. So to confirm that it's not the case, or that is the case or not, we have to do a DNA genotyping. So we pick up certain genes that will characteristic for each species, which is displayed on the agar plate with one band. So, okay, if you have this band here, this DNA here, we know this is the agent subgenital termite. And another one, that's a different location, another band with another band for has to be for Formosan termite. So we know that if it come from Formosan, agent subgenital, you have this band, from Formosan termite, you have this band. So when we look at those and we identify those two characteristic bands, then we do the DNA genotyping with the offspring, which is the worker and soldier from the same colony or the hybrid colony. What we found is that there's a two band exists. If the mother and father are two species, mother have one band, father have another different band, but that the offspring have a two band, both band. That's pretty much indicate hybridization had occurred. This is not that female are storing the sperm of same species anymore. So we have to confirm using DNA to confirm that is the case or not.
Okay, and in this case, you did confirm that you do have hybridization. You have a
two
brand
band.
new species.
Yeah.
Gotcha.
Yeah, we have the offspring have a band, DNA band for both different species of termite.
I gotcha. And so now that we do have a confirmation that we do have a brand new species that potentially can become a threat, from from a PMP's perspective, and
Mm-hmm.
from obviously property owners and perspective,
Mm-hmm.
there's been much talk in when we listen at CEU trainings and in other type of
Mm-hmm.
trainings that pretty much the in South Florida the termite
Mm-hmm.
industry is pretty much either dead or it's just not as thriving as before because of products like Termidor, which is fipronil, are doing such a
Mm-hmm.
great job of controlling termites that it's not as big of a problem. And even with products like your Centercon system,
Mm-hmm.
for what do we have to look forward to if this does become a problem, and what is the potential challenges with having that mentality that we're okay, we're safe because this is doing such a great job?
Well, for one thing, for the PMP, for termite control industry is concerned, we have to confirm its pesticide we're using today still work the same way against this hybrid species, hybrid population.
Gotcha.
We don't know.
Okay.
We have no idea. My hope is that it's probably the same, but we need to confirm that.
Gotcha.
From the homeowner point of view, though, is that now you have a certain termite variety that it's going to grow faster than their parent species, which indicate to me is that by the time you notice that the termite in the house, the damage may be more substantial. From homeowner point of view, the repair cost may be more costly, and that's probably one thing we worry about. And once we confirm as far as the susceptibility to termiticide is the same, from PMP point of view, it's probably not a very big issue, but from homeowner point of view, it is. That's one thing I think the homeowner from the Tri-County area, from Dade all the way to Palm Beach, will probably have to, face in the near future. Now, that is assuming that hybrid is sterile. Now, if hybrid is fertile, meaning that this hybrid population will actually continue to produce and then spread further, what this means is quite big, because as far as we know, Formosan termite distribute from all the way to North Carolina to Florida, and then from south down there, from Caribbean all the way to Brazil, it's Asian sub-Saharan termite. If hybrid can reproduce and they are not sterile at all, eventually we may see this hybrid population distribute from North Carolina all the way down to Brazil. And that is quite a substantial problem we are facing.
Right. So we're not just looking at something that potentially is a problem just at home, but potentially a problem in all those parts of the world where you're now, like Hawaii and Taiwan, where, obviously control or access to control is not as readily available as we might have it here in the States. Yeah.
Well, especially in Central America, South America, some country in the Caribbean too, the control, like you say, is not as more sophisticated or really available. Hawaii and Taiwan are just like the U.S.
Gotcha.
They have a very well-developed termite control industry over there. I don't worry about them. But something worry about me is South America.
Gotcha. Okay. Yeah, well, I really do appreciate the time that you have taken. I wish you the best of luck at finding out what's going on in Hawaii. And is there anything that you would like to add to this that I probably haven't asked that I should have asked? Yeah.
Well, we are still looking for potential hybrid population. It already exists. And like I said, one of the urgent questions we need to answer is that if this hybrid population is fertile or sterile. So if any PMP out there finds some unusual termite that they may suspect could be a hybrid population, we'd like to know. Bring them in, and we may even do DNA genotyping to confirm they are actually hybrid or not. And that's something that if you can spread the word to the industry in this area, we appreciate it.
Yeah, no, most definitely we'll be getting it out. Actually, this should go on the air by next Monday. So we should be able to get it published by then and get it out right away. Well, I thank you. I also want to give special thanks and mention to Stephanie Osorio, Aaron Mullins, Lucas Carnahan, Sarah Bernard, Duhay Kelly, Urgarelli, and Ronald Pippin for technical assistance. We also thank Robin Giblin Davis and Ed Vargo for their insightful comments that aided you, I guess, in this part of what you're currently doing, because you obviously didn't do this all alone, and you've had some help, and we'd like to thank them also for this, and thank you very much for your time. I know you're very busy, and you've taken time to do this, and I really do appreciate it, and hopefully that it will help educate the PMP and the general public of what's actually going on with this at this point. And whenever you have something new, I'd like to be able to discuss that with you, and I thank you very much.
Thank you. It's my pleasure.
All right, so you have a great day and have a great trip. Thank you very much.
Thank you.
Bye-bye.
Bye.
Well, this has been the Pest Geek Podcast, and we thank you for listening. Also, we'd like to talk to you about a new segment that we have at pestgeekpodcast.com. It is our news feed that we provide, and we provide news from all over the world, from sources like PMP Magazine, PCT Magazine, the EPA, and also many more sources that we newsfeed from. And you can get that directly in your email by going to pestgeekpodcast.com and looking at the newsfeed. You can also subscribe to our Twitter feed at Pest Geek Podcast at Twitter, and there you can get all the latest news of what's happening as they happen around the world, and with anything related to the pest control industry. Also, we've added a new segment to pestgeekpodcast.com where we have cool tools and tips, a segment there. Then you can check out the tools that are available that are coming out recently that we're looking at, so that you can become a better pest control technician. We thank you for listening, and until next time, we want to give you that killer edge. Thank you for listening to the Pest Geek Podcast. If you have enjoyed the Pest Geek Podcast, please give us a rating, write a review, or subscribe to the channel. You can join the Pest Geek Society by visiting pestgeekpodcast.com. Thank you for listening. See you next time.